Do you feel a chill? Is the air humid where you are? Is it windy? These questions posed to a group of people are sure to return a variety of answers. A meteorologist has to have an unbiased answer based on a uniform method of measuring the elements. Meteorologists worldwide use weather instruments to gather measurements and data and communicate them in standard formats. The most basic tool used by meteorologists is a thermometer. Thermometers measure temperature. You may have a thermometer with a liquid like mercury or alcohol inside a sealed glass tube. The liquid expands with heat and contracts as it cools. Other thermometers have a coil that is made of two different metals sandwiched together and connected to a pointer. This bimetallic design takes advantage of the principle that different metals expand and contract at different rates with temperature change. So when the air warms, it pushes the pointer higher. A hygrometer is used to measure humidity. Professional hygrometers use animal hair or human hair connected with a mechanism to a pointer to give relative humidity. As water vapor increases in the air, hair lengthens. This is why on a very humid day, it's harder to keep your hair in control. In dry air, the length of hair decreases. You may have noticed that some wooden doors or drawers in your home stick or creak when humidity rises. Any object that can absorb moisture will react to humidity changes. Basic hygrometers use an absorbent material bonded to a coil of metal. As humidity changes, the material changes length to stretch or squeeze the coil and make the pointer move. Other instruments determine humidity by calculating the rate of evaporation. Once you know the humidity and the temperature, you can use a formula to calculate dew point temperature. That's the temperature that air must be cooled down to in order to form dew. You can directly measure the dew point temperature by noting the exact temperature when dew forms. While dew point gives an indication of the absolute amount of moisture in the air, relative humidity does not. Relative humidity indicates the amount of moisture in the air relative to the moisture itself and relative to the air temperature. Wind has two components that have to be determined: direction and speed. Wind direction is fairly easy to observe using a wind vane. It's an instrument often seen on older buildings and on boats that points in the direction from which the wind is blowing. Some wind vanes have ornate and even whimsical designs with an arrow to show where the wind originates. Wind is named for the direction that it comes from, rather than where it is going. The wind vane used by a meteorologist may not be ornate, but it is typically connected to a dial or meter to record and display the wind direction. Wind direction is also displayed at airports using a windsock. It's a brightly colored tube of fabric connected to a pole. A windsock allows pilots to see the wind direction to aid in safer takeoffs and landings. The amount of the windsock that stretches outward also gives pilots an idea of how strong the wind is. Wind speed is measured by an anemometer. That is an instrument with spinning cups or propellers. The stronger the wind, the faster they spin. Many anemometers are built into a wind vane to resemble an airplane without wings. The wind vane points into the wind, and the propellers measure the speed of the wind. This combination instrument is called an aerovane. Wind speed can also be determined by the frequency of sound when air passes over a tube in an instrument called a sonic anemometer. Knowing the wind gust is as important as knowing the steady wind. That's added information on the strength of weather systems. This security camera shows the destructive power of extreme gusting wind from a tornado striking a modular office trailer. The high wind is generated by very low pressure. The instrument that measures air pressure is a barometer. Air pressure tells us how strong a high-pressure system is or how deep a low-pressure system is. Barometers, like those you would find in a home, use a sealed metal chamber with a partial vacuum. When air pressure increases, it squeezes the chamber. Springs and levers make the needle on the display move to a higher value. When air pressure decreases, the chamber expands and moves the display needle to a lower value. Traditionally, these weather instruments were found at airports since weather is critical to aviation. They would be housed in an instrument shelter, a northward-facing louvered box about chest high over a grassy surface. Depending upon the needs of the user, weather instruments are now set up on instrument towers, buildings, factories, bridges, and roadsides. Many of the newer electronic versions of the instruments are solar-powered and automated. With greater reliability and durability, they have replaced the traditional instruments. This provides a great quantity of regular data, although the data lacks the visual sense and judgment of a human weather observer. A rain gauge is another instrument and perhaps the simplest. It is a tube or container left in the open to catch rain, which is then measured. Rain gauges that report data in real time often use a miniature bucket that tips and empties each time it captures a specific amount of water. Every time it tips, it sends a signal to indicate an additional amount of rain has fallen. Other weather instruments have very specialized purposes. A transmissometer is found at airports. It measures the transmission of light through air, simply called visibility. Visibility is reduced by particles. Any solid or liquid or combination particle floating in the air is called an aerosol. And aerosols can be natural, like pollen or dust, or they can be particles like soot, ash, or pollution. These tiny objects in large number create haze. Ceilometers are also found at airports. They measure ceiling of clear conditions, which is the base of the clouds. Transmissometers and ceilometers are critical to safe aircraft operations. More specialized weather instruments can measure ultraviolet radiation, ozone, and even the electric field in air. Lightning is preceded by an increasing electric field, so an instrument known as an electric field mill can give warning to the likelihood of cloud-to-ground lightning. There are also instruments that detect actual lightning strikes to the ground. Weather instruments are an extension of our senses. They have the benefit of being objective and consistent. However, all weather instruments must be calibrated, maintained, and properly positioned to avoid contamination of the data. For example, a basic home outdoor thermometer in direct sunlight will show a reading too high. A thermometer mounted on the outside of a wall will pick up some of the building's temperature rather than just the air temperature. If a thermometer is placed too close to an air conditioning unit, there will certainly be false readings of air temperature. A hygrometer placed adjacent to an exhaust vent won't always display correct humidity. A rain gauge that is under a tree will not accurately measure rainfall. Wind vanes or anemometers mounted too close to a wall or between buildings cannot accurately measure the wind without a bias. All weather instruments allow meteorologists to create a record of weather and weather events. Instruments afford a universal method to measure, communicate, and share weather data around the planet. Weather instruments enable us to monitor thresholds for comfort and safety, and to define and catalog storms and weather events by magnitude. This data is used in studying past climate and in making future predictions of climate and weather. These are weather things.